Hello, everyone. Welcome. Today, I am interviewing Andreas. He is the principal research scientist at Pieces, and we're going to be talking about all kinds of cool AI stuff and stuff that I literally have no idea about. I saw that he wanted to talk about transformers. I don't know. Do you know what that is? We are going to find out. Andreas, do you want to introduce yourself really quick before we get into all these crazy topics?
Yeah, thank you for the introduction. So my name is Antreas Antoniou, and I started in Pieces about 6 weeks ago. Before that, I was in another startup doing small models and what people call distillation. And prior to that, I did a postdoc and a PhD in machine learning, specifically meta learning and multimodal learning. So there we go.
Very cool. One thing that I am curious about, I've heard a lot of people regret doing PhDs. Are you happy that you ended up doing a PhD or do you regret it?
I think it depends the field you do your PhD in, right? So like I think if you do your PhD in an computer science engineering field, right now they're pretty like hot, so to speak. So I was going in because I want to understand deeply like AI systems and what neural networks basically the systems that were um, starting to build what we call deep learning today about 10 years ago, right? And I was like, I need time to tinker. How do I get somebody to pay for that time? And I was like, okay, scholarships, and I tinker, and then depending on if I am good at tinkering and structuring my tinkering, then I can have papers out of it, and that makes a PhD. So, I thought of it of my first real job being a passion project, very lowly paid passion project, but a passion project nonetheless, and managed to get into a really good prestigious program in the University of Edinburgh. Um, it was cohort based. It was a master's plus PhD integrated. So I did that. And generally, I would say that I do not regret it one bit because I did it out of a clear passion for what I was doing. But maybe luck or I don't know, something else. The field I was doing it that machine learning AI is something that in order to do at I think a very high level, you generally need either a PhD on or to have been accepted in one of the programs in the big companies that you basically spend 4 years doing things. They don't call them PhDs, but you need that kind of time to build yourself up for the kind of background and the intuitions. And, you need to try a lot and you need to both build, write, and teach to kind of have the right uh, recipe together, so to speak. So, yeah, I would say I do not regret it, but I do know people that have felt regretful, both in my field and in other fields, but especially more so in other fields.
Right. I guess it really depends on what you're studying and whether you really enjoy studying it or not. Because if
Mhm.
you go all into something for multiple years and you find out, like, hey, I really don't actually like this, and then you're writing these really long research papers about it, I'm sure it could be extremely unpleasant. But also, one thing I was curious about, so you studied like AI, machine learning, things like that during your PhD. Was AI a thing when you started that? Like, did
So
it?
basically, yeah, basically the main reason I started my PhD in AI was there were basically a number of things. Like I finished my undergrad, and I was like, okay, what are the technologies that excite me and I think have the chance to have a big impact on things? And in my head, I was finishing my engineering degree, so I was aware of like, quantum computing, there was AI, there was nanotechnology, genetic engineering, and energy generation, like solar power, etc. Right? And I was like, okay, I'm very passionate about nanotech, AI, generally speaking. And then I ran into a talk at TEDx. At TEDx, I think it was just a TED talk back then, um, about deep learning, and it explained how, like, oh, in 2012 there was this big sort of paper that produced like 25% gains on tasks that were previously unsolvable, and basically solved like a very hard problem on called the ImageNet challenge, where you have a million images, they belong to 1,000 labels, 1,000 categories. Some of them could be, I think 300 of those are literally different breeds of dogs. So you have to be able to like do that really well, right? And before that, people used heuristics, which is like if statements, if not this, then that, etc. And very, very, I guess, simple features like this is an edge. If you have square next to square next to square in this direction, you have a corner, you know. But people had to work on every individual feature for their whole PhDs even. And then deep learning came along and it was like, nope, we just throw me on the data, I'll learn all the features for you, so automating all that way. And now the focus was on model design, our algorithm design, right, on how you design the system that trains things, right. And I saw that, I was like blown away. I'm like, yeah. I went to my supervisor at the time. I was like, you know what, we were doing drones before, we're not doing drones anymore, we're going to be doing some deep learning for a dissertation. So he believed in me and he was like, okay, let's do it. And that put me on the track to start working with deep learning. There were competitions like Kaggle that allowed me to learn a lot more from competitions, and frameworks like Keras, which was one of the first like decent libraries for deep learning. And I went from there. So the answer is that there was like the fundamental of what exists today was there, but we needed to explore it more, tinker with it more in order for it to mature into like LLMs and the multimodal models used today and the video models, image models, etc. So yeah, everything about them was there. We just needed to explore it more and figure out how the right recipes.
Okay. That's really
Yeah.
interesting. Yeah, so you kind of jumped around a little bit during the whole PhD
Mm.
experience. So I'm wondering now that you work at Pieces, right? So
Mhm.
bringing it back to Pieces. Now that you work at Pieces, did you actually like talk about this in the interview and stuff? And was that really interesting to, Savo or whoever was interviewing you at the time?
We actually talked more about cutting edge AI and what's happening, and also like sort of the philosophy of what drives me to the things I want to do, and how I whether I like to take risks or not.
Okay, that makes sense.
Which is it's something very important in research. Basically, like many people, if you haven't been exposed to the edge of the cliff, the abyss, right, where you're constantly bungee jumping into it and trying to find something new, um, it can be very intimidating for people to explore that unknown and to fail, right? And people that have done that a lot, they learn how to fail optimally, and they take failure more as a way to check in a corner, and then more about the world and you can move to the next corner. So yeah, I think that was more about the talk. But yeah, so yeah, there wasn't much of the PhD parts, I would say.
Okay. Well, I'm sure your PhD is still helping you out with whatever you're doing. And that's kind of what I want to talk about too is like, what are you actually doing at Pieces? I know you mentioned like failing and trying again, taking
Mm-hmm.
risks and everything. I do think that is really, really important for probably any job that you do. Like, if you allow yourself to fail, you're going to learn so much more than it's somebody who's like always playing it safe. But I wonder how that actually applies to your job at Pieces and what you've been doing lately with the as of this video release, LTM 2.5 is going to be out, so people are
Mm-hmm.
going to know what it is. So I'm curious, like, if that is applying to this because you've recently started. So I guess the last couple of weeks you've been working on LTM 2.5 entirely.
Yeah. So essentially, what happened was, before I even joined Pieces, there was a conversation about, we want to do this very hard, crazy thing, and maybe it's not possible, but we want somebody who can try this thing out, which is I want to run the performance of an LLM, and I also want it to run in half 100 milliseconds, and I also want it to run on low energy. And I'm like, okay, so there are potential ways to try and do that. So the abyss, right? We sort of scope out the abyss, and we're like, these places look interesting. There's gonna be a lot of bungee jumping, but that's part of what research looks like. So we build a nice portfolio around that, or what we could do, and we go to work. And at the end of all that, we managed to very quickly replace, I would say, at least 60% of the models that Pieces was using with our micro or nano models, depending on on who you ask. I don't think the name is like clear yet for anyone in the industry, but very small models that go below 100 million parameters, which is, well, you'll hear people talking about half a billion, a billion, a few billions, but almost nobody would talk about like 100 million or less, which is what we're doing. So we scoped it out, tried it out, and I was surprised as well as to how well some of these models were performing compared to LLM baselines. In fact, exceeding most LLMs, with the exception of the model that was used to generate training data for the small models, right? So that model is the teacher who knows everything. Like, it's the Oracle model, so it would always get 100% performance on that task. Whereas the students, so for any other LLM out there, we're outperforming except for the teacher, which is you cannot do better than the teacher basically. And for that to work, you can imagine like an LLM is sort of like a huge brain, right? That can do lots of different things, journal task, executioner, etc. Whereas what we were trying to do is get this thing like specific skills to live in small models that we can run very efficiently and locally. So much of the work is deciding what tasks do we need doing, how do we break them into small tasks that a small model can do really well, and then figuring out how to train such a model, essentially. So this is what we've been doing, building small models that can do everything from figuring out what time your current query relates to, all the way to lots and lots of different types of tags related to software, person working on something, the sort of overall task that you're trying to do. So a system can sort of tag what you're currently doing. And on top of that, we also have nano models that can do some of the OCR correction parts of the pipeline. And we're moving on to the next thing. So there's very few parts that don't have a nano model right now. And we're probably going to be able to get to a complete nano model pipeline in the next 3 months, I'd say.
Yeah, I do think we're going with the name Nano model. I don't know what's going to be ending up as the popular term in the future, but hopefully everyone will stick to the one we're using. I have heard Sam refer to it as micro models, but then I'm like, Sam, we already decided on nano models. so
Yeah.
so yeah, we're going with nano models as far as our branding and everything on the website. But one thing that I did want to ask you, you mentioned OCR. So I do remember talking to some other engineers about that, like clean OCR. So I don't know, could you explain that really quick? So for people who don't know what that is?
Yeah. So OCR is optical character recognition, basically. And for LTM 2.5 to function, you need the ability to be able to stare at the screen of what the user is actually staring at and extract text, in the future images, and overall understand what is happening. So even though you're just grabbing text, you need to be able to understand the narrative. So we start with a very cheap, but very cheap and middle performance, so to speak, way to extract text, so that it's fast and low resource. And then rather than spending all our compute on the first OCR pass, we do a cheap OCR pass, and then we have a bigger, beefier model that runs every I think 20 seconds, that does the cleanup. And so we have a model that receives text and garbled text and confused text and makes it into a clear piece of text about what is happening, and then it can also infer the narrative at the same time.
Okay, so with OCR, basically Pieces is capturing all of that text, and then we're running some nano models to kind of filter what's important and then save that somewhere. Is that sort of the gist of
Yeah.
what's going on?
Yeah, I mean, in reality, we do once we do the cleanup, everything is stored. But then we do have models that are able to pick out narratives and filter it in different ways, so it becomes very useful to the user. But we do try to store things so that when we get better on our model, locally, of course. Everything is locally stored. So when the LTM gets better and you install it, that can do better with your existing data, which is something very, very nice.
Oh, okay. That makes sense. Because I know, have you heard of Microsoft Recall? There was a whole drama where they were capturing screenshots and I guess people
Yes.
didn't like it. But the difference between OCR is, are they using OCR with these screenshots, or is that a completely different thing? Because I know a lot of
So,
these other sort of like long-term memory tools, a lot of them are capturing screenshots or even like video, screen recordings, and then using that information later on to reference. So what are we doing differently from,
yeah.
capturing screenshots versus what we're doing with OCR?
Yes, so it was one of the things I discussed in my original interview actually with Savo. So I was also concerned about stuff like recall and how they could become tools for spying on people, right? So I was talking to Savo and I'm like, yes, I need something to follow me around. I need it in my life. I always wish there was a product that could do that. But I don't want that data to be going to anyone else other than me. And so that's the difficult part. Like we're doing OCR. I believe Recall is doing forms of OCR as well, but we're doing it in a way that remains fully local. All the models are running on your machine. So your database and everything is yours. We don't really touch it unless you very explicitly allow us to for post-processing or whatever. But that's on the user. And we are working on what we call a how did we name it? I guess it was fortress mode. So the fortress mode is like everything becomes completely local and you can run it without internet, basically. So so we're working towards that. As things currently stand, you can still do that yourself if you basically there's a copilot component, right? So they have the LTM component, which is the memory component that is fully local. But the copilot part, which you can be your own copilot as well, you can use ChatGPT with it, you can use Cursor with it, or you can use our own copilot with it. If you're using our own copilot with it, you have to choose a model. We have a selection of like 30 or more local open source models you can use, but there's also much better cloud-based AI models that users may choose, right? So once they choose that, some of the highly selected data from LTM will have to be sent there, but those are already cleaned up, remove any personal identification, stuff like that, going to the LLM. However, going forward, we are gonna like sort of have very specific configurations to make sure that the user can choose fully local mode, even for the copilot, right? So as I said, LTM is fully local, but the copilot, the chat model, so to speak, is not necessarily, but can be if you choose the right model from the settings.
Right. I do know with the Copilot, you can choose local models if you want to. And I did hear that with these nano models coming out, that it will be a little bit better with, using local only mode, because some people using like Windows laptops in the past were facing some slow response times, especially with local models. So hopefully that's going to get better. But one thing I wanted to ask you is that since we're making this switch to nano models, and we've talked about them, throughout this interview, I'm wondering like what is the limit of using large language models, and like why did we end up switching to nano models in the first place and trying that out?
Right. So let's think about it this way, right? You can use a aircraft carrier to go fishing, right? You could grab a fishing stick and go on the aircraft carrier and fish for fish, right? It's still a boat, but it's the resources you need to spend to do that would be exponentially higher than a small fishing boat, right? So that's kind of what's going on. Like you have the LLM that it's the aircraft carrier in this context. But if you want to do highly specific, things with surgical precision, then you can actually just grab a much smaller boat, so to speak, that's specialized for the specific thing, spend much resources, and it also makes the thing runnable locally even possible because some of the big models out there, like Gemini 2.5 Pro, which is like making the rounds and changing everything nowadays, it's probably in the trillions of parameters, and you would need a supercomputer just to run it locally. So, it becomes infeasible basically. And on top of that, you want it to be fast, and you also want the thing to be running on your machine without disrupting what you're doing. So it has to also be low on CPU usage. So as you see, the only way to do that is to get a smaller boat and customize the boat, so you can do your job efficiently, essentially. So that's the big sort of problem, right, with LLMs. The fact that they're so resource hungry, the fact that many of them are anyway behind API walls, so you can't really use them anyway, even if you had the capacity to run them. Yeah, so that's basically it. It's just more efficient. You can run it locally, whereas before you couldn't. And and one more thing I would say that we noticed when interacting with pieces is that even if you have the fastest internet in the world, an API call will cost you about half a second. And if you imagine you're doing like 5 calls, one after the other, that's already 2.5 seconds that you've been waiting for something. Whereas with micro models, we're doing sub 100 milliseconds for each call. And as such, it goes from, oh, I'm waiting a bit, to it's happening real time when I get a response. So yeah, that's the other thing.
Well, I am very excited for that. Sam did tell me in the previous interview, so there's another interview out there on YouTube about nano models, and he told me that the response times are going to be way faster after this release. Have you
Yeah.
actually tried like the staging build or anything, and have you noticed that?
Yeah. I've definitely sort of played with the staging build, but as the guy who actually ran all the benchmarks, I can tell you that basically the more you use the nano model, the faster it kind of gets, because of the way we've packed it up. If you only use it once every 5 minutes, it might take about 150 milliseconds. If you are using it multiple times per second, because of something called a warm-up period, once the small model warms up, then it runs in like sub 50 millisecond timelines. It can go all the way to sub millisecond even, depending on your hardware. So
That's crazy.
if you're running on like an M1 laptop, for example, I can tell you for a fact that it will be less than 1 millisecond.
Wow. Wow. Well, I'm excited about that because definitely I've tried to do like use pieces while I'm on a flight, and I don't pay for Wi-Fi. I'm like, no, I'm not paying for Wi-Fi on a flight. But I try to use the local models, and every time I'm like, I wish they were faster. So I'm hoping that this helps with the speed of local model responses as well, especially using LTM. Do you think that that will help that
Yeah.
problem?
So if you use LTM 2.5 and you choose one of the nicer models out there, like the Microsoft 5.4 model that came out recently, it's 14 billion parameters, but it runs, in my own experience, very, very quickly. And so you get responses relatively quickly. Um, Imagine the fact that a year ago, running even an 8 billion parameter model on a laptop was a pipe dream. So being able to run a 14 billion parameter model relatively fast on your laptop nowadays is kind of crazy. And I think this is going to keep scaling to the point where you can run these kind of, between 15 billion all the way to like 100 million parameter models super, super fast. Yeah. So that's why local models are going to become more and more powerful over time.
I think so. I think local is a future because a lot of people, when they think, long-term memory in regard to like AI, long-term memory or capturing context on your device, people are like, oh my God, all of my data is going to be sent to the cloud and Steve Jobs is going to see it and share it with everybody. So
Yeah.
I think that, having it locally is really, really important for people. Otherwise, they won't use it. Like they won't even try it. So I think that people, if it's not, 100% local, people are probably not even willing to like turn it on for a second.
Yeah.
Especially if you're very privacy conscious, which most people should be, but unfortunately some people aren't. So I kind of want to like switch the topic. It's pretty much related, but you mentioned something called transformers before we started this talk. I wonder if you can like define that and tell us about transformers in general, and then we'll go on from there.
Yeah. So just to get it from the beginning, I guess. So this kind of deep learning revolution, so to speak, started in 2012 approximately, slightly earlier as well, but many people would place it on the 2012 ImageNet moment, so to speak. That was like one of the first successful and very, very public demonstrations of the power of neural networks, artificial neural networks, on their ability to learn tasks from data with small amount of labels. But like nowadays, we need even less labels. Labels being annotations from humans. We're going closer and closer to, basically zero requirement for annotations as we improve things. But anyhow, so just to get to the story, there's these neural networks. You can imagine each neuron being a different Lego block, and there's many ways to use Lego blocks to build different looking things in the world. For example, there's particular flavors of Lego like Bionicle that were more bionic looking, right? So you could use those to make robots that could move actually. Whereas you have, the more standard Lego blocks that are better for like buildings and cars and stuff like that, and so on and so forth, right? So, a neuron, for example, you can imagine it's just like sort of a Lego, and the way you choose to connect them is called an architecture, a neural network architecture. And depending on the architecture you choose, you can learn different tasks faster or better, or both, depending on what you're doing. So, for a long time, what is called the convolutional neural network was the main player, solving all the image tasks, the audio tasks. Google Translate, the very first version, was running on a combination of convolutional neural networks and something called the recurrent neural network. So lots of different architectures, basically. And then in 2017, a bunch of folks in Google, sat together, and they came up with this architecture called the transformer architecture, which has since eaten the world, I would say. So it's the fundamental block we have behind literally every LLM out there, and most of the image models and video models and audio models that you find out there. So if you're using 11 Labs to do your voice, probably a transformer. If you're using Suno to do music, it's probably a transformer. If you're using ChatGPT, it's absolutely a transformer, and so on and so forth. So it's like the one Lego block that seems to be ruling them all at the moment, right? Yeah, so I guess that's as far as we could go. But just to make it more concrete, one of the fundamental shifts that Transformer introduced is that rather than having a very specific connectivity pattern with respect to your inputs and outputs, the model itself can actually learn to rewire its own architecture to some extent. So it allows itself to learn its own structure given data. Whereas before, the structure was defined and you could only change the weights of the neurons. Whereas now the neurons can actually choose how to connect with each other. And this is done with a method called attention, the attention mechanism that you may have heard out there. So that would be my long story short cut of things.
Okay, I do appreciate the intro. So I do have one question. I think that this kind of comparison can be made with a lot of different things. Like, I can't think of something off the top of my head, but let me try to think. Oh, what is that? Okay, like a cat is an animal, right?
Yes.
But
Yes.
an animal is not a cat. Okay, does that make
I
sense?
would say all, yeah.
So
Yeah.
are transformers LLMs or are LLMs transformers?
Okay, so let me see. So I would say that all cats are mammals, right?
Right.
Um, so the transformer is more about it's the mammal in the situation,
Okay.
and an LLM is a specific version of a mammal.
Okay. So there's other types of transformers, not just LLMs. Well, could
Yeah,
you give like a couple examples of what other types of like things fall under the transformer umbrella?
yeah. So let's think about this way, right? So if you grab a transformer and you train it on next token prediction on the whole of the internet, you get an LLM. If you grab a transformer and you train it on um, next token prediction on an image, you get a model that can, given a few pixels, it can complete the whole image. So you get the system that can like generate images. And then if you train something that can complete text to image, so imagine you go on your Wikipedia, you collect data sets from that have like an image and then a caption below it, right? So imagine that you tokenize both the image and the text and you train on next token prediction, you get a text to image model, right? And so on and so forth. So depending on what you grab architecture, you grab a task and you grab a data set and you combine them and you get a model. So transformer is the architecture. There's two more other parts, right? That if you modify, you can get a completely different set of things. Like there's a set of things where you combine transformer with lots of self-driving car data, and you get the Tesla self-driving, fully self-driving motor or whatever they're trying to get to, right? So different results. Probably one of the most popular ones out there is so you probably have all used stable diffusion or something along those lines to generate images. That's also part transformer, part convolutional network. It's a bit of a hybrid. And also there's like things like Suno to make music. There's probably what was the name of it? The one that came, oh yeah, the Sora model from OpenAI to generate videos, etc. Every single one of these is a transformer with a slightly different task, slightly different data, basically.
Okay, cool. I need to tell Hannah. Hannah's our SEO person. She's a head of SEO. And I feel like you now have to write an article about transformers for the Pieces blog.
Okay.
That's what I'm going to tell her. I'm going to tell her we need a transformer article because when I think of transformers, all I think of is like Optimus Prime from well, what is that? What is that? I don't even
For
know what
transformers.
oh yeah, it's just called Transformers.
Yeah,
uh,
so it's funny. Like whenever I open a lecture, I'm always like showing transformer, like the original thing that changes the electricity patterns, right?
yeah,
Because that's also very important. Like it brought the electric, it's part of the electricity revolution. And then you have the transformers, as in the robots,
right.
and then you have the transformers, as in the models. And to be honest, the model name for like I don't like the name transformer because I don't think it represents what the model is actually doing. So yeah, it's an opinionated take, but I definitely would have preferred a slightly different name, um, because now like everything is the same. Transformers, 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 and
Exactly.
nobody
We
knows what
made
they're
an
talking
article
about.
about comparing the three. We've got like some a Venn diagram or something.
Yeah, yeah.
Yeah, that would be cool. So I do want to get to this one thing before we finish the interview. You
Mhm.
mentioned the needle in the haystack problem. I never heard of it before, so I really wanted to talk about it. What is that? And could you tell me why it's so hard for LLMs to solve it?
Yeah. So a needle in a haystack problem is a situation where you may have millions of events. A user query, in order to be answered, requires like one of those events to be found, and you need a way to find that one sample that you need to answer the question with quickly, accurately, and without breaking the compute bank, right? So it gets harder the less compute you have, and the larger your database becomes. So this is like front and center one of the biggest problems for pieces to solve. And the main reason that transformers are not great at solving that is, well, there's a number of reasons. I would like enumerate the top three off the top of my head. One is that they have a very specific limitation on the amount of context that they can take in. So usually you will hear 100,000, maybe a million. I think the most recent models are like 10 million tokens, and tokens are not words; they're subwords. They're usually like think about it as 2.5 characters, right? So, as your database gets bigger and bigger, it becomes harder and harder to solve that problem. Sorry, that's a cat.
A cat! Oh my gosh.
Yeah,
What's your
this is
cat's name?
this is Dante.
So
He's the
cute, so fluffy. Oh my
yeah,
gosh. That
yeah,
is so cute.
it's
We
my
we
best
need to
friend.
do oh, what if we did like a post on social media and we just had everybody's pets from Pieces?
I think that would be great. Like, can you guess who this pet is from?
Oh, that's a great idea. Yeah, like a match game. We'll have
Yeah,
the person's face and then be like, whose pet is whose. If
yeah,
you get it right, you win a Pieces hat.
yeah. Needle-in-the-haystack. So
That is a
anyhow,
good one. I'm writing that down. Pieces, remember that for me, please. I can't wait
so
until we add audio. I know that that's on the roadmap.
100%.
Essentially, we need
Yeah,
audio
yeah.
because I don't
Been
have
pushing,
captions on right now.
been
But
pushing so hard for that. Been pushing so hard for that.
so important, honestly, because a lot of stuff, it's not, people don't have captions on all the time. So, for example, if I was a student and, well, actually, I am a student, but if I was watching a lecture or something and I had the captions turned on, or I didn't have them turned on, then I wouldn't be able to get anything from that lecture really, unless I like went and opened up the transcript and scrolled through it. So I would love if I could, watch something or not watch it and it's just playing, and then later Pieces like, by the way, you were listening to this lecture, not paying attention. Here are the main points. That
Yeah,
would
yeah,
be
yeah.
excellent.
It's
Yes.
pretty funny, but like about 2 years ago, I wrote a script for my partner that would listen for her lectures and then give her a summary.
That's really great. See, that's what we need. We need to add that into Pieces, and then it will be all set, really.
Yeah, yeah.
So
And people like the Pieces CEO Tavo, like he wants you to be on all the time so you can just yell out the answers and the ideas he has, and they get recorded.
yes.
Yeah, I suspect what he really needs is something that directly connects to his brain, but I think that's the next step.
Well, yeah. I mean, when I first talked to Sabo, he mentioned that what he's building here at Pieces, what we're building is Jarvis, pretty much. So I am very excited for Jarvis/Pieces
Mhm.
of the future. And on that note, I'm really curious, what do you think the future of AI looks like in like the next 5, 10-ish years? I know that's a pretty big range, but maybe we'll do like 10 years. We'll do 10 years. What do you think the future of AI looks like in normal people's lives in 10
Mhm.
years?
So I would connect that actually with the last point about the needle in the haystack, just to like
Mm-hmm.
completely get that out. So as I was like saying there, transformers do have this kind of inherent limitation of the context. And also because of the way they are trained, even if something is in the context, so even if you could afford to put your 9 million events into the context, there's a high probability that they would miss some of the context when they're trying to find the right answer. And that's because they have a bit of an attention problem. They tend to focus too much on early or late events. And the reason for that is because they are all pre-trained on next token prediction. In order, like the most informative things about predicting the next token in general, if you imagine all the books and all the Reddit posts and everything that is happening out there, is the words right before the token you want to predict and the words at the very beginning of the instructions, right? They are the ones that inform you about the task, and the other ones inform you about what happened recently. And and as a result, many of the LLMs out there have a huge blind spot that looks like a curve, um, that gets increasingly worse towards the middle of the context that it's seeing, right? So as you imagine, that creates problems for needle in a haystack. By the way, this kind of weird, like, attention, let's say, error that happens is also called lost in the middle problem. So these are the two sibling problems that Pieces has to invest a lot on. And so in terms of how things look in the future, I would say that we need a modified version of the transformer that has actual long-term memory that can be saved and retrieved precisely, and it would need better ways of pre-training them so that they don't end up developing this problematic behavior of like missing the middle, etc. And I also think that they become multimodal. So there's audio, there's video, images, and potentially all sorts of other sensory modalities that can go into it and out of it from actuators. Ultimately, I think they will exist both in embodied robotics and devices around us. So you may not think of as imagine you had a fluffy ball that has an AI in it and can also float around the house, right? You wouldn't think of that as a robot, so to speak, but stuff like that, like very soft, small everyday items that can now have AI in them and do things and help you out around the house, etc. So I'm imagining that ultimately it's all gonna be embodied in one way or the other. Yeah, so that's what I
I
think.
could see that. I could see, everything being connected. Have you seen that movie? It's a children's movie. I think it's called Smart House. Have you seen
No,
that?
I have not.
Okay, it was I think it was popular in like the early 2000s. So for kids in the early 2000s, I remember it's sort of like not a horror, but like a kids horror. So the house goes crazy. I don't really remember all of the details, but literally everything in the house was, smart or had AI integrated into it. So I sort of see that as the future, but not in a creepy way. I do wonder, just to play devil's advocate, if
Mhm.
we do have all of these AI devices that are just normal objects,
Mhm.
do you think that people's memory is going to get worse because they rely on all of these items, or all of these I guess all of this context is being collected somewhere, so you don't have to worry about it or worry about forgetting? Do you think it's going to get
Yeah,
worse, or do you think it's actually going to help people's memory?
I think like with everything, right? If you don't use it, you lose it. So like because of AI, I've been using more vibe coding tools, etc., to accelerate my productivity by like 5 or 8x. That means that I become better at being a manager, at describing a problem, at knowing exactly like what the model might do wrong and getting ahead of that. Uh, but I also end up being somebody who's less, building the actual code base itself all the time, and so I become slightly worse at that. Um, I think I don't think there's a silver bullet to retain all of your skills at every single time. That's how the brain is built. It doesn't want to, spend real estate and energy to retain skills you're not using. It doesn't make sense to it. So I was thinking about that in the context of education before. How do we make sure our kids are, they don't end up like losing fundamental things that make them adaptive human beings? And I think the answer to that is education that emphasizes the importance of doing things, even if you can't do them in an automated way. Just knowing when to do a bit of that, a bit of the other thing, so that it stays in your DNA, so to speak. So I do think the memories of people can get worse if we don't educate people, and even make like people like to play games, right? So maybe one way to fix it is to make games that actually train your memory, so that people actually have a motivation to do memory games, right, or to do other sorts of things on that type. So I think that if we go all out and we use agents for everything and we don't use our memory is going to change to be more about remembering what the query was, right? Similar to what Google search did for many people, right? So for most of my PhD, I knew the right search to get to the answer rather than the full answer. But it's also important to like, for a number of things, to study them down for a while and actually make them part of your foundational knowledge, right? So I think it's gonna be a game, a bit of a game there, figuring out what sorts of types of memories people want to have, and depending on that, they're probably gonna need a sort of memory coach, or maybe games. Maybe there's a way to make it so that you don't have to think about it. I don't know.
Yeah.
I think games are nice.
Games are good. I think did you know, this is just very random, but so there's different types of, martial artists that compete in the UFC, like the Ultimate Fighting Championship for those who don't know. I don't remember exactly. I think it's Thailand. It was I'm probably wrong. Okay, there's this one country where there's these fighters and they have a higher than average win rate compared to other fighters, and they train in a specific type of martial art. I don't know for sure what it is, but the way that they train is really interesting because when they're actually training, they don't fight in a way of like I need to win, and it's in that sort of intense, sort of angry way of fighting. They fight in like a very playful way. So when you see them fighting, it's sort of like they're dancing and they're smiling, and they interviewed a couple of those different fighters and they were like, oh well, actually you learn better that way. Like when you're
Yeah, it's
happy
true.
and when you're having fun, your brain is like relaxed and absorbs the information better,
Yeah, yeah,
and you
it's
stay
true.
safer,
I
right? You
think it's
don't get
true.
injured as much.
It shows up in education a lot, in
Yeah.
pedagogy and etc. And also like in my own personal experience, like if I'm doing creative work, if I want to make good decisions, I need to learn how to I had to learn in how to keep myself in that playful place, even under pressure. Because the moment you give into that sort of all or nothing fear based mindset, you start thinking more like how to run away rather than how to go and um, find the opportunities and learn from this experience. And because you're trying to get away from the experience, I think it definitely does something to the way you learn as well. But mostly that all or nothing thinking just squashes your, colorful, continuum of thoughts into two things. And as you might imagine, having a variety of possibilities is probably going to lead to more interesting and adaptive responses. So I don't know.
Yeah, I do think so. I think that's definitely true. And I'm very optimistic towards the future of AI in education. I think it's going to make things way better because originally, we have one teacher teaching a class of like 20 to 30 people. And then some people, they vibe with the teacher and they learn the stuff and it's all good. And there's a lot of people that are like, this is boring. And then there's some people that just are maybe so behind that they have no idea what's going on. So I kind of think that AI is going to level the playing field for everybody because you can adapt whatever you're learning into something that is interesting for everybody. I think it's going to result in sort of like a customized learning experience for people instead of the one we're using now, which is like, hey, here's the curriculum and here's how we're going to teach it. And then maybe like once a year you get one good teacher and that's it. I'm hoping that things are going to get a lot better and
Yeah,
more gamified. That's
we
why
do
people
have the
love like
tools.
Duolingo, right? It's
Yeah,
gamified. So
yeah. I think we have the tools, but I think we are also lacking the education of how to use the tools. Like most people are gonna go on ask the question to get the answer rather than asking it in a Socratic dialogue where you can actually learn about the whole thing, etc. So like in the university, we have some initiatives that we're trying to figure out what's the best way to use LLMs to like educate our students. And one of the best ones is, student shows up, LLM asks some interesting questions about who they are, what they like, what the background is, and then they can use whether it's a favorite character or a past degree they had or something to translate the terms and make it more interesting. But also, um, you, very often you find that you have intuitions from previous experiences that are directly translatable into the new thing. You just don't know which one it is. And for example, for example, people that train dogs and cats, etc., right? Various of those principles are called reinforcement learning, and there's a AI version of AI, reinforcement learning that is quite similar, and there's a very similar intuition about it, the thing you're doing, but you may not know that. But then if you tell the AI, I was doing this before, I also like that character, etc., then it can customize that for you, and go from there. But I do think that people need to learn how to use the tools, and they need to be incentivized because we tend to be I don't know. I don't know if it's always been this way or not, but I think we are very greedy with our time. So we will rather just go and get the answer and copy paste it and go home. Um, there are some people that love actually getting to the bottom of it and understanding it, but most people wouldn't do that. So I think we need to properly incentivize and explain to people why they should do the other one. And I don't know how to do that yet, but hopefully we can. I think teaching people from a young age to how to use tools in a curious way and how rewarding that experience is of discovering things can become its own reward. At least that's what it is for me and many other curious people out there. So yeah, I don't know. We'll see what happens.
We'll see. I do think we should do some sort of live stream about AI and education, and we should just talk about it with people, because if we do a live stream, we'll get a bunch of other people's opinions as well. I feel like that would be good, because we sort of went way off topic here with this, but it's okay. I really like talking about that, though. That's like one of my favorite topics in AI is AI and education. So let's do that. I'll remember it probably. If not,
For
hopefully
sure.
will remember it for me. But anyway, we've been going on for a while, so I do want to say thank you for being here and talking to me about all of this cool stuff. One final question: what is your favorite thing about Pieces?
Right. Well, my favorite thing about Pieces is that I wanted something like Pieces to follow me around, and so I can basically be like, you remember that thing we did on that day where I was talking to John and listening to that music at that time, and can you remember what it was? Or being able to automatically like figure out my stand up or make a report, or even more relevant, automatically make documentation of whatever the hell I just did. You know, because it does feel like every time I had to write documentation about the process I just did, I felt in my head, we have the tools, we have the technology for this. It should be automated in the future. So yeah, I would say for now, it's just the ability to recall information from a long time ago and combine things to write really good reports or documentations. But I suspect it's going to become more and more about even for the meta process of how I do things in general. And time tracking. I think tracking across different apps or different projects automatically is going to be a huge deal as we go forward.
Yeah, I could see that. I could see that. We could replace like Waka time or something and do
Yeah.
time tracking. I think that would be cool. One thing I do really think we should kind of implement in future versions of Pieces is some sort of gamification, like some way to make it like more fun. Um, but we'll have to think about that. We'll think about it. Maybe we'll do something about gamification and brainstorm. But anyway, that is it for this interview. We're going to turn this into a blog post as well. So you're going to see a bunch of quotes from, I guess he's on this side, Antreas. We're going to put a bunch of quotes in there. It's going to be cool. It's going to be linked below this video. So go check it out if you don't want to watch the whole thing. But I guess if you're here, you've already watched it. So thank you for sticking around. We will see you in the next interview or the next video. Bye.
Thank you very much. Bye.